Welcome back to the Fire Break. I'm Steve Wolf. As you know, the Fire Break is sponsored by Team Wildfire. We're doing some experiments around here to try to figure out if we can put out wildfires with jet engine. Check it out on the web, teamwildfire.com. I've got a really cool guest today. I have Luca Carmignani. And if you don't think that's fun to say, try it a few times. It's great. Carmignani. And Luca is a wildfire advisor at the University of California. Which campus are you at, Luca?
Well, so that's the tricky part. And by the way, thank you, Steve, for inviting me to this podcast. So I'm based at the South Coast Research and Extension Center, which is in Orange County, but it's not part of UC Irvine. So I'm with the University of California Agriculture and Natural Resources, which is a parallel branch to the UC campuses that, you always hear about. But so we have about
I
like
see.
nine, 10 locations across the state, and I'm the one based in Orange County.
Okay. I'm glad you said all that because all I know about is UC Berkeley, UC Irvine, whatever.
Yeah, I know.
There's a
It's
lot
part
of
of my
UCs out
job
there.
to do the branding.
I to focus on the branding. So I've read a lot of the papers that you've written, and if you don't know this, Luca is a very, very prolific researcher, scientist, experimenter, and he's written a lot of papers with really long, cool names about fire this and fire that and smoke this and that. Luca, could you tell me about some of the work that you've done and I know you've done a lot, but what do you think is right now the most important of your work in terms of influencing how we go about combating wildfires?
Well, that's a good question, and because as you mentioned, I worked on several different aspects of fire research throughout my career. I actually started from flames on small scales. I was looking at the flammability of solid fuels in reduced gravity, specifically for future space missions to make sure that the astronauts are safe. And then I expanded it and continued it into wildfire research. And one of my main topics was the smoldering, understanding the smoldering of wood, and specifically under which condition it transitioned to flaming. And because, for example, in during wildfires, you have a lot of fuel on the ground, both living vegetation but also dead fuels. For example, logs or branches that are decomposing or that are different state. So those fuels usually tend to smolder and not burn directly into the flaming regime. So I definitely spend a lot of time trying to figure out the that particular problem of the smoldering. And this was I started this research when I was a postdoctoral fellow at UC Berkeley, and I'm still involved on that research. It's hard to say which one is the most important because that kind of led me to another very important research that I'm currently working on, which is related to the flammability of vegetation and specifically in urban areas and all the vegetation ornamental plants that you have around homes and structures.
I spoke with to a guy in Australia, and he refers to the process of landscaping as placing the fuels.
That's one way to see it. Yep.
Right? Where do you want to place the fuels around your house?
Well,
Uh,
because
so,
some
so what have you found out?
Well, so usually I tend to tell people that, when we're talking about fuels, we're literally meaning anything that can burn. And this is not only plants, it could be a trash can. In the so-called wildland urban interface, we have a lot of urban fuels and, they have nothing to do with vegetation. That could be a deck, could be, as I mentioned, trash. So usually what we want to focus on is the area very close to the structure, specifically the first region, within a few, like 1 meter, 1.5 meter, or if you prefer feet, 5 feet. That's like the most important area because all the embers, will tend to land there. So if you have anything that is ignitable, then you're going to expose the house directly to flames. So I
I
would
see.
say,
Okay.
yeah, that's like very, very important area around the structure.
So you've got your vegetative fuels, and then you have your man-made fuels, which would, which, wood and particularly plastic. I've heard plastic referred to as solid gasoline or
Yeah, of
frozen
course,
gasoline.
not all the plastics are the same, but a lot of
No.
plastic material burn pretty well. That was
Yeah.
actually a lot of my research in microgravity. I was looking at plastic material like plexiglass, acrylic materials, and they can burn really well.
So you're thinking really far ahead, such as once we go to the moon or to Mars, and then we set up shop there, and then we ruin that atmosphere, and then we make that overheated, and then that place has a fire problem. How is that problem? How's that fire going to behave?
Oh, that's gonna be a $1 million question because
Right. Okay.
there you have, yeah, if you, let's say you have a little ranch on the moon, well, in that case, you're gonna have, yeah, fuels that not really sure what kind of fuel you'll find, but definitely the gravity is not the same level that we have on Earth, so that's gonna affect the fire behavior substantially because you're gonna have a buoyancy that is, like the hot gases that go upward, you're going to have it at a much lower level, so you're going to have more vaporized fuel that stays close to the fuel surface itself, so that
I
might
see.
create more problems.
More
That's,
heat.
yeah,
Right.
yeah, and the
Okay.
heat transfer changes as well, so yeah, that's going to be a whole new topic.
So have you ever like made a little fire and gone up in the vomit comet and see how it behaves in low gravity?
Well, that'd be cool. The problem of the comet, I would think that there's not much oxygen. So you still need
Uh-huh.
oxygen for that. So that's why, a lot of people say, "Oh, why were you studying like flames in space, but there's no oxygen?" But the reality is, if you want to have humans, then you do need oxygen. And if you have oxygen, then you're at risk of fires. So, it's all relative.
And sometimes you might not have free oxygen in the atmosphere, but you might have chemicals that contain sufficient oxygen within them to burn, like with our batteries, our
Yeah,
EV
totally.
batteries, right?
Yeah, we talk about oxygen, but in reality, you just need an oxidizer that could be, another chemical.
Okay. So I looked you up because I had read one of your papers, and then there were, I think, 6 authors on there, and I reached out to each of you, and you're the one who got back to me. So I appreciate that. Thank you.
Yeah, of course, my
Uh,
pleasure.
so tell me about the interface between academic research and where that research becomes practical tools that are used for fire mapping, fire progression, fire avoidance, etc., firefighting.
Yeah,
How long does
totally.
it take for things to trickle over?
Well, well, there's like different answers to this, but usually we have like the academic field and academic research that tends to solve more like fundamental problems, that sometimes are a little bit disconnected from the practitioner side. You have people on the ground fighting the fires or preventing the fires, working on different aspects. So how do we connect these two worlds that not always talk to each other, even though they're working on the same problem? So my position is actually pretty unique in that because I am an academic with the University of California, and but I am also an advisor and I do a lot of outreach. So I do bring the research that is done on the UC campuses, by UC academics, and bring it to benefit the practitioners and communities that I work with. So to me, it's one of the most important thing, when we talk about like fire research, is to understand what is the final goal, what is the objective. Is this something that would actually benefit, our knowledge or our behavior in preventing catastrophic fires, or is just something that might never be used. So to me, it's very important to keep that practical aspect of it, and also, very another very important aspect is to promote that knowledge. Once you have that knowledge, if you just keep it for yourself, then it's not that useful. But having outreach and communication definitely, expands the applicability of that knowledge. And you might not see a direct application of your research, but once you talk to like more peers, like people on the ground, you understand. Oh, maybe I didn't intend to apply this research in this way, but maybe it can be applied this other way. So I feel definitely the communication aspect is a very important one too. I don't know
And
if I
what
answered
about
your question.
crossover between the journals? Right? Because so let's say you've done all this research and you put it in an academic journal, and that gets read by other academicians who are probably not firefighters. Because firefighters read Firehouse magazine, they read Fire Engineering, and they read Wildfire magazines. So, do you ever try to repackage things that were written to an academic audience as articles that could go to the firefighting community?
Yes, definitely. I haven't done it recently. I haven't gotten a chance yet, but that's definitely something that we do, like with my Fire Network team. It's definitely very, very important because once you have, I mean, it's fine to have an academic article or something very specific, but then how do you translate it to other people? So maybe writing a researching brief or something that can be understood by people, that are not in that field directly, it's extremely beneficial. Personally, I've been doing a lot of like short videos and social media content that can help, people that might not necessarily know a lot about fire to understand why we do what we do and why it's so important, for example, to focus on that zone around the structure to prevent the loss of the structure itself, explaining why that's very, very important.
Yeah.
And with all the issues that we have with the editorial companies and all the publications, because that's a whole another Pandora's box, I feel that's very important for communicators to, expand the audience as well.
Absolutely. Yeah, and the people respond much better when you tell them the why and not just the what.
Exactly. Exactly.
Right.
And
So
also
what are
my
some of the whys?
Well, like we're thinking about that zone around the structure, for example, and people are like, oh, I don't want to remove my mulch because mulch is very beneficial for my plants. But then you show them, how the fire can approach the house by burning through that mulch. So, you make them understand why you're talking and why you're saying what you're saying. And visuals, for example, like other ways to communicate besides just the classic paper or classic presentation, those can really help understanding the problem, in my opinion, at
Is,
least.
I agree with you. Yeah. Is there a paper or research project you're working on right now?
Yes, now I'm right at the beginning of a new research project that I've worked on for a few months. I've finally finished the new research facility that will allow me to burn plants. And plants, I'm talking about ornamental plants that are a few feet tall, and in that way, my main goal is to find a kind of like a methodology to assess the flammability of plants, because as you're probably aware, there are testing methodologies for assessing the flammability of different materials, different assembly for structures, but there's not really any methodology to assess the plants, and there are some standard assessment, for example, the cone calorimeter that you can use to kind of get an idea about the flammability of the chemicals inside of the plant, but it's not going to give you the full picture of like the role of the structure of the plant, the branches, the part that is dead or not, or simply the effect of irrigation. How's that going to change if I irrigate more or less the plant in my backyard? So that's my goal, and I'm right at the beginning. I finally got all the permits last week, so I'm ready to start burning next week, actually.
So tell me the truth then. What's harder, doing the research or getting the permit?
Well, I guess the political correct answer is the research, but definitely getting the permits is a lot more time consuming and yeah, harder to do.
Okay.
Yeah.
So, but as a result of this research, you'll be able to make some conclusions, hopefully, about what the safer plants are, because a lot of people, well, I don't know about a lot of people, I see something as a plant or it's not a plant. and I don't know too much more about the plants. You'd have to talk to my mom about that, but she's the gardener, right? Um, but I guess given a choice between different plants, you could, because we talk a lot about deer resistant. These are the deer resistant plants, but you know, never hear a scale of these are the flame retardant plants.
Totally. And I live and work in Southern California, where, for example, the drought tolerance of plants is extremely important to reduce the water usage. So you find out there like a lot of lists of plants recommended for drought tolerant landscapes or for pollinator landscapes, and people want to have like all sort of plants in their backyard depending on their taste, and what they want to do. But at the same time, you can combine these recommendations. For example, combining a drought tolerant plant that is also more resistant to fire. And when I talk about resistant, I'm not saying that you can blow torch it and the plant is gonna stay there. It's gonna burn eventually, but it's gonna have some characteristics that are not gonna make it ignite as a bomb, in 3 seconds. So there
Right.
are things you can do. It's still gonna burn, but it's gonna burn less than other plants. So that's the idea.
Okay. And so I guess there's a lot of aspects of flammability to vegetation, right? One is simply how easy is it to get it to light, and then the other is how many calories, how much heat is released when it burns, and then what's the rate of that release, right? If you eventually get it to burn, but it burns very slowly, it's not going to make so much radiant heat at once to light your siding on fire.
Exactly.
But if it
Exactly.
all goes off, right? Okay, so
Yeah.
you have a lot of things you're going to be measuring.
Yeah, yeah, I do. And as you mentioned, there are like different aspects that people usually look at. One is ignition, how you ignite it, and that's a huge, I feel there's a huge debate there, like what's the best way to ignite the plant in a realistic way? And probably, the answer is like there's not a single answer. You need to test it in
Multiple, yeah,
different ways to simulate embers, for example, or a flame contact, or sometimes even radiation. The radiant heat is strong enough that you might be
yeah.
able to ignite parts of the plant. So, yeah, so there are a lot of different parameters. The goal is to find a way to like parameterize, not parameterize, like find the driving mechanism behind this ignition and heat release rate that can
I see.
also be used
Are
by
are
the
you
people.
yes? Are you afraid that you're going to be blacklisted by nursery owners? And they'd be like, "Don't sell him the plants; he's going to burn them up."
So to avoid this issue, I've actually trying the opposite approach. I've been contacting nurseries, and people that are already working in that field. There's a lot of resource conservation district or other like organizations that work on the natural environment that have a lot more knowledge than I do on the ecology of the plants, and so it's important to have bring them on board and discuss them. What are the things that are important for you, or what are the parameters that we should look for? Because those people are also the ones that often are on the ground with homeowners and residents, helping them, establishing those defensible spaces. So it's very important to me to collaborate with all the people that work in a certain field to try to have, first of all, a very diverse point of view, and like, have a debate on what's important, what's not important, and what to measure, what not to measure. And from there, have solutions that can benefit all of us.
So you're going to invent the VFR scale for the vegetation fire resistance, and just like I buy a refrigerator and it says my efficiency is 7.0, and I'll be able to look at plants in the nursery and it'll tell me how flammable they are on a little tag.
Yeah, sort of. Like you have
I
those
mean,
tags like, oh, water this plant this much if you want it to thrive.
right.
So maybe we can have a tag, saying, yeah, don't plant this one like next to your house or something, or under a tree.
And
Because yeah.
yeah, and what about the side of the house? Like I live near the Marshall Fire, and in there they found that the ember attack was always on a certain side of the house. So you might
Yeah,
make decisions about, okay, this kind of plants on this side, a different type of plants on the other side.
Yeah, so it's hard to generalize because it really depends on a lot of factors. It depends on the location of the structure. If you're on top of a hill, if you're in a canyon, what is the preferential direction of the wind? If you know that the wind is always blowing from east to west, probably that side of the house should be more conservative than the other side of the house. And it might not be always the case, but at least it gives you a good like risk risk reduction approach, based on your location. And also, if your house was built in like 1960, you probably have some construction methods that are different from the ones used in the early 2000s. So that's another aspect, and it might tell you where you want to prioritize, where you want to focus your attention, depending on your location. That's what I usually tell people. There's not really one solution for everybody. It really depends. The priorities are different from for people, and some people might want to make sure that they have the if they're on top of the hill, they want to make sure that the side facing that canyon is going to be very hardened. And with hardening, usually I mean like retrofitting or improvement of some home components. So yeah, it really depends, and that's my answer usually is depends.
And sometimes you have, oppositional cases. The most drought resistant plants, would be the fake plastic ones, but they might be also the most fire hazard.
Yeah, totally. And I've been told too, I was like, why don't we use artificial trees around the houses? And, in theory, you could. They're probably not gonna burn if you have a metal tree, but is
Right.
that really aesthetically pleasing, or like what about all the benefits for wildlife, so or erosion of the soil. So there's all sort of aspects that you need
Metal
to
roots too, right?
yeah, yeah.
Right. Yeah, well, I want to see the beetles come attack my metal tree.
Yeah, that would be interesting.
Right. Ultimately, that's not a bad idea. The leaves are miniature little solar panels.
Oh yeah, that would be cool,
That'd be beautiful, right? A lot prettier than the stuff on the roof now. So you work as as a team of academicians. I guess, right? These are not solo projects for the most part. Um, what are the things that your team is most interested in terms of like I know? So now you're going to go into vegetation, right? But
Yeah,
I bet
so
I bet you have a long list, right? Because you've been in fire a long time of studies that you want to do. So what are some of the other things that you're working on or going to work on?
So definitely the mulch flammability, and with mulch, I don't know if you're familiar, all of those, usually the organic materials like coming from chipping or other plant residuals or just the composition of organic material. So that's something that we don't really know how it affects the fire spread around the house. We know that it burns, and we know that it can help the fire reach in the structure, but what are the guidelines, for example, of placing it around the home, maybe at a certain distance, or having the mulch layer that is a given depth? Because we can have 3 inches, we can have 10 inches, it really depends. So, what are those parameters that you can play with and residents can play with to have what they want, because mulch, for example, is beneficial for water retention. So keeping those goals, but at the same time, not increasing the risk of fires. So that's also why I'm saying it's very important to collaborate with people that are not in fire or like, that work on different aspects of sometimes it's called like urban living, or even if you're in a more rural community, like these multi-beneficial, multi-perspective approaches, I would say. It's very
Have you
important
ever
to do
come
this.
across a sorry? Have you ever come across a perspective that you sought out that completely negated the path that you were going down with something?
Well, the mulch one is an example, and because mulch has been pushed a lot for its water retention property, it's very important for drought resilient landscapes. But you see, if you go around like looking for houses, a lot of flipped houses have the mulch right next to the siding of the houses. So, to do a lot of to work in the to reduce the water usage, you create a more fire hazard. So I understand the intent, but if we don't work together, it's not gonna happen. So we need to like understand each other's perspective and see how we can compromise.
Uh, I'm going to go back to what you were talking about, getting smoldering materials to reignite.
Hmm.
I'm guessing you blow on them, right, to get them to reignite. But in what in I would imagine a big wildfire comes through, everything above the surface burns, and then you start an emberization process of what's burning below the soil. But if that reignites, there's no more trees around it, so it's only going to be a threat, I'm guessing, if it becomes an ember cast source.
Well, not necessarily, because if you have, for example, a fence nearby or a deck, those are parts that sometimes have some wooden boards that are like, a little bit decomposed or a little bit older than others. So it's possible that those embers are gonna find a crevice or something that can
I
ignite
see.
those materials. So, even if you have something that might look not that dangerous in the first place, it can become dangerous after a long time. And smoldering is a process that can last for a very long time. And
Thousands of years in some case, right? In a coal
yeah,
mine.
it can almost go undetected. If it's underground, if you don't see the smoke coming out, it might go undetected for months and then come out, where you have these. In Southern California, we have Santa Ana winds, which are very dry, from the desert, very strong, and you have one of those, and that little patch reignites, and yeah, it can create a lot of problems.
So, what are you working on to reduce the Santa Ana winds?
Yeah, that's a great question. I don't know if I have the resources to do that.
Okay, so we're going to work at a more micro level.
Yeah, you might need a lot of those turbines to fight the
Yeah,
Santa.
right, right. Yeah, and yeah, what we're experimenting with. Actually, what I wanted you to experiment with is if you have, adverse winds driving a fire towards you, and you push back with jet engines, how far can you push back to create a neutral zone or a positive zone? And that's going to depend, I guess, on the how much the weight of the air, how much of it you can get, the volume. If you
Yeah,
put other materials, right, if we add flame retardants that are liquid based into it, we're creating a much more dense bullet, essentially, being fired into the wind. I'm hoping you could figure out how we could calculate some of this on computers and not have to, do it all in real life.
I don't know if I'm the right person for that, but that sounds like a fun project.
Well, maybe you know the right person. I don't know.
Yeah,
I'm
we can
sure
chat about
everybody
it.
knows you. Okay, excellent, excellent. Anything else that you want to share about your research? New directions, areas that you think are going to hold a lot of promise for the WUI?
Definitely something that I would like to explore more, and there's not a lot of resources out there. Is like the role of trees and vegetation on embers, close to the structure. And because some people say, oh, if you don't have any trees, you're fine, the house is not gonna burn. Other people say, oh, but the trees also work as ember blockers. If you have all of these
Mm.
embers that are coming from a fire, the tree is gonna catch some of them. So there's a lot of controversy around it, and I feel that if there is controversy, there is opportunity for research. So I think that's something that I would like to explore more in the future.
Yeah, that would be fascinating. Like sacrificial trees that you plant, and their job is to catch the embers and
Yeah,
protect your house.
the only problem is that, when you deal with trees and structures, you go to like pretty large scales. So doing it
Yeah.
experimentally is tricky because, all the fire safety procedures that you have to maintain. And, just for me with small plants, definitely getting those permits required a lot of work with the fire marshal to make sure that, everything was safe before burning the plants. So I can imagine with that with trees it will be a whole new game.
And these aren't the same fire marshals who approved the New Mexico prescribed burn, right?
No, no, no.
Okay, just checking. All right. So, what about houseplants? plants that are in my house, my ficus tree and my spider plant. And
I mean, I think those plants are fine if you have like vines along the siding of the house, that's different. But if they're inside, then you could just treat them as all of the other, indoor fire risks that you have in the home. But usually inside the home, the major risk is like electrical faults or, something related to the electrical equipment or appliances. I wouldn't focus too much on the plants.
okay, just focus on how I plug them in.
Yeah, yeah.
Got it.
Christmas trees are probably a lot more dangerous than, an ornamental plant.
That's right. So no more Christmas trees. Well, all right. Not if you have a live tree, water it. Right.
Yeah, no, water definitely. The NIST has a yearly competition to predict how much heat is released by Christmas trees that stay dry for like 2 or 3 weeks. And when you see those Christmas trees burning, it's actually like pretty impressive to see the flames that they can generate in just not watering them for like a few weeks. So yeah, it's something that people should
So,
keep in mind.
so they do that as an annual competition, and whoever can guess the number of calories without going over.
Yeah, you need to have the most accurate prediction of the heat release curve during time. It's pretty fun to play.
That's wow, science games. That's
Yep.
great, Luca. What's the best way for people to reach out to you for more information or to follow up with the studies that you're working on?
Yeah, well, if you want to follow me on social media, my name is SoCal Fire Guy. You're gonna find me on Instagram, X, the old Twitter, and also TikTok. And I try to create like videos and content that can help communities preventing for wildfires. But also we have the UCANR Fire website where you can find all the information and all the resources that we have not only for wildfire preparedness but also for forest health and landowners that are curious about what to do, to prepare for wildfires. So yeah,
Well, that's
definitely
nice
check
of
this
you.
out.
That's very nice of you to mention them. But of course, it's gonna be a lot more fun to follow your social media
Oh yeah.
and hear it directly from you, right?
Yep,
But
totally.
a little less dry. No pun intended. So excellent. Look, it was a pleasure meeting you and getting to chat with you for a few minutes here.
My pleasure, and thanks for having me.
Absolutely. This is Luca Carmignani. He's the fire fun guy at UC in California. So please do check him out. Look for him on the web, and I'm going to put a link right here. I don't know if it's here, here, or here, but somewhere next to Luca's picture on our teamwildfire.com website, you'll find a link to Luca's information. Thanks so much for joining us today. Listening to the Fire Break. We're sponsored by Team Wildfire. I'm Steve Wolf. Until next time, be safe.
Thank you.